Hi Umbra, how's it going? Screaming, as usual. Not as usual, that was evil of me, why did I say that? My bit rate's in the red. Whatever, it's like always in the red. We're going here. Is this gonna work? Wow, look at me actually properly turning off my sources so I don't have random stuff showing up. I'll move chat up a little bit. You can see Umbra screaming. I'm gonna rewrite this code. I think we maybe did some of this before. This is the rotating axes thing. Maybe we didn't. Maybe I'm lying. No, we didn't. We didn't. So this is... Hi, by the way. Hope everybody's having a good day. This is for numerical solutions for dynamics. And we are working on some rotating axis stuff. So the idea is... Oh. Okay, you can see some of my values. Sorry, I just got like jump scared. I didn't think it was not going to be cropped. I guess I could just move it over more. Oh wait, but I want you to be able to see the... Yeah, you can see that. Okay. So yeah, we're working on the merry-go-round problem. And the merry-go-round problem is if you have two people, or I guess normally it's just one person. Oh my gosh, hi Garv, how's it going? Maybe Garv can backseat hard enough that it solves my problem. The backseating, not Garv. That was a strange... I don't know, I'm... My brain's not working too well today, guys. It's like the first I've spoken today. Also, I've just been locked in. Anyway, person standing on merry-go-round throws a ball. Yeah? Throw a ball. And... Go away. No, I want to play the... Whatever, they throw a ball and the merry-go-round rotates and they throw it in a straight line. But if we look at it in the rotating axis, it kind of looks like it's curving, even though it's not. Because of the Coriolis effect. It's not an actual acceleration. Look, this is what I said. We have to... I'm going to rewrite this. So my issue is that this sucks. So that's cool. Basically the issue is, well, right now there's a lot of issues. It's supposed to be going up was the first issue, and it's not doing that because the way that I set up these axes are kind of jank. So in this one we want our rotating axes. The merry-go-round is like spinning around in a circle, right? And our rotating axes are following that. But what we want to say is like we're looking at the rotating axes right now, so they're actually not going to be moving. So our global, like our fixed coordinate system, is actually going to look like it's rotating the other way. So that's what these black lines are. But right now, it's not actually doing the right thing. So I gotta rewrite it. Because what I did was I defined the rotating axis, but this is not correct. I think what I'm gonna say is I'm gonna call this F E1 for the fixed axis, because those are what's actually rotating. But for the fixed x-axis, because okay, I said that in our case, bulb velocity is not affected by the rotation of the axes. It's not affected by the rotation of the axis. So first term is 0, right? In this is our velocity in a rotating basis. Our second term is a static velocity A in a fixed axis basis. But in a rotating basis, it will rotate. So we can define axes that rotate and then use those to bring VA into the rotating basis, which is a fancy way of saying we're going to make V rotate even though it's not rotating. But it needs to rotate the other way. So it's not doing that right now. So I have, sorry, I'm just making it not so bright in here. So we've got this fixed X and Y axis. And I want to change this to like a norm, like that. Easier for me to type. Norm, look like I mistyped worm. So this is the normalized angle that we're rotating at. But we want to rotate our axis the other direction, because right now our whole thing is rotating clockwise in the negative direction, but because it's rotating clockwise, we want to rotate our fixed axes the other way. Do I like The Offspring? That's a band, right? What music do they play? I'm assuming you're not just talking about like the word. Oh, you're gonna go far, kid. The John Arbuckle dancing song. Is that too boomer? No, I know them. I don't really listen to. In this point in my life, I don't listen to that kind of music as much right now. But I do enjoy that one song. Oh God, it is. That's just the one that I know of there. It's just like off the top of my head. I love that video so much. He's dancing his heart out. I think the issue also here. Do you like my children? I know, I was thinking that. I was thinking like, oh, you mean just like the word offspring, or like the offspring, the global offspring? I haven't met your children, so I wouldn't know. I times angle from the original, so we won't use I and I plus 1, just the first vector, just 1. That doesn't make like any sense, but that makes sense to me. Also, global fixed axis rotates opposite of our rotation. Rotation. Ratatouille. Okay, theta rotation. So this is fine. This is not fine. We want to dot it with not FE1. We want to dot it with 1 1 1 0 0 and 0 1 0. Did I? What the? What the? Oh. Wait, what the heck is happening in this? Oh no, we're fine. Sorry, I'm like 0 1 0. Okay. So now we have the components in that into components of rotating axis 1, rotating axis 2. I guess I should probably define it. Rotating basis 1 is gonna be, I mean, I guess I could just say, yeah, I don't even need to. And then RE2, just in case we need to change it for whatever reason. Defining the rotating axis, the rotating basis. So instead of that, we're gonna just say RE1. That's RE2. Oops. Okay. This was me trying to fix my life, so we're not gonna put that in there. I was trying to fudge it to see if I could get it to, because it's undershooting. I'm not gonna rotate it like that. This is fine, I think. And then this is updating the fixed basis. Yeah. We should be okay. So let's see if this works now. Let's see what it does. Not the correct thing. What are those axes doing? Why are they going down? Also, what? How is my what the? Oh, no, oh. How do I do this? I do need to rotate. I need to rotate V as well. So wherever I'm rotating these, I need to rotate V. I'm just gonna steal this and I'm gonna change it to V ball. Do I do it before or do I do it after? Well, it's not a perfect circle, so it looks weird. Yeah, yeah, that is also an issue, for sure. Do I rotate it before or after? The scaling is not actually wrong, it's just because I have this vector in here. If I got rid of this vector, it would be fine. But I just wanted to see what the velocity of the ball is every time, so I can make sure it's going right. Also, I don't know why, but I think that needs to be up. This is supposed to be, I think I need to rotate this first. Now, do I rotate the next? No, I rotate it after. I think it's that. I don't know, chat. Also, I think I need to change this to I plus 1. That. And then... I don't love it. I might need to change it. It might not like it. I have like all my stuff kind of... Yep. Damn it. Okay. That means I need to change... Oh no, leave that to be. This needs to change to this. I plus 1. And this needs to be I. And then that means these need to change to this. I need to store everything as columns, essentially. And then we rotate it, and then we update the positions, and then we rotate the fixed axes. God damn it. It's not right. Okay, what's wrong? Oh, I know why. This, which is kind of annoying, but not really that annoying. Damn it, what? No? REI, maybe it needs to be... Maybe REI needs to also be 1 by 1, you know, like this. I showed my friend my... I'm lag. Automod. I showed my friend my outfit, she called me a bad bitch. Why is she so mean? Aw. Automod doesn't like your joke. No. God damn it! What the heck? What? 101 by 1? Where? What? Where? V-ball, what do you look like? It's doing nothing right now. Wait, sorry, V-ball. Well, V-balls, Yeah, I changed it. That should be a column. Right, these are fixed now. And these should be columns. So why is it not a column? I love that it's 101 by 1, 3 by 1. Is it because this needs to be I? I don't like my joke either. Aw, it's a good joke. Don't worry about it. I thought this was right. What's happening? What's... This is like, we're setting the first row Like, we want the whole first... Wait, oh. Wait, I think it might need to be the other way. I... Like that? Oh! What happened? Oh. That. No, it doesn't like it. Wait, where? Oh, 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 oh. Oh. Are you 3 by... This should be I. Wait, but it worked on the other one. What the hell? Oh my god. What's wrong? What's wrong? V-ball is like all... I'm saying set the column at I. Yeah, that should be right. Am I goofing it? Am I goofing it, chat? I don't want to be goofing it. XP is 1 by that many. See, FE is 3 by 102. That's what I want. So I'm doing the wrong thing right now. Oh, wait a second. This should also be I plus 1. But this should be this. This should be this. My brain hurts. Now there's an issue here. What is it? Dot product is not right. Is it not like this vector here? Can I see what this vector is? FE, we take the whole first row. Wait, why does this work? I feel like this is wrong. Isn't this saying we take the whole first row and then just the first column of it? Isn't that like a bajillion? What's going on, guys? I feel like I'm losing my mind. I don't know why this isn't, like, doing the thing that I want it to do. The dot products are fine. That should just give a number, a number, a number. Should it not? Or these aren't fine? Do these need to be these? I can't think of any other reason. No, that's also an issue. That is 1 by 3. 3 columns. I don't like that. I want 3 rows. So that's that. But this is getting 101 by 1. There we go. What about that? What about that? No! Wait, oh wait, no wait, that was right. What? Guys, I don't know. This is like a little silly. This is saying the first row and then all the column. I don't want that. I want the whole. I want all of the rows in column I. Oh, that's what it means. Wait, it didn't work still. What? Wait, but V-ball 2 is giving me. Because isn't it because you're using a semicolon in the second half? But that makes it go into 3 rows. I want 3 rows. This needs to be a column vector. And I want to say in the... Oh wait, no, this is flipped. This is not correct. It should be this. I don't know why that's not letting me do that. The left side is 101, but do I need to like clear? Is it because I haven't cleared? Let me try and clear the program. It might be like not running it right. Like V-ball 2B should not have an issue with like being 101 by 3. I don't think I said it like that. See, we can look. It must be where I set the first thing. No, see, this is right. Okay, so that it does set up as a column. Oh, but now there's an issue here. Okay, yeah, so it was just... Okay, I wasn't losing my mind. It was just not doing that properly. There we go, okay. Index must not exceed 3. Yeah, because it needs to be doing this instead. That's fine. I'm fine with that. That's normal, that's good. Same issue here. Let me, you know, just like for fun, I love to transpose all my matrices. MATLAB's so bad with vector storage. It's not that bad, it's kind of on me, I'm not gonna lie. Okay, it's doing something. It is not rotating V. Why is it not rotating V? Okay, these axes are rotating right though. These axes are rotating correctly. We need to rotate V. Why is it straight up just not rotating V? It's supposed to rotate it. What? Wait. It's not rotating it. Oh. No, I know why. It's because I set 1 to be this. And then I reset. Yeah, this needs to happen after we set this. Okay. I think. Oh! I don't know what button I pressed. How is it still not rotating? What? Chat. Chat, please. Chat, why is it not rotating? Wait, I didn't... Wait, no, it should be... Is it because I'm plotting it wrong? I'm plotting it after, maybe? Oh, wait, no, I'm... Okay, I can't just... Let me put it back. I think it's fine there. I'm just dotting it with VA every single time. But wait a second. Wait a second. No, okay, yeah. V ball to be equals, V ball to be I1 equals, there we go, and then we change this and we say V ball to be I think, and then we rotate it, and then it goes. Please rotate. Fuck, A and B must be the same size? What? Oh, oops. Column I. There we go. Okay, that is, Oh. Okay. Wait a second though. No. It's fine. It's kind of stupid. It's fine. Wait, now it's not rotating! What the fuck? Wait, why is it not rotating? It's not right. It's not right. Wait, why is it not rotating? Wait, what? Oh, no, I see. The issue is like... Oh my god, I need to... It's working exactly how I imagine it in my head. I'm just gonna call this the axes rotation. I'm gonna make a second one that's not DI. Because this just needs to... It needs to happen. It needs to happen, chat. Don't worry about it. Make a norm. Times I. I could probably just dot multiply all of them by I. Get rid of this. There we go. That should fix it. And then come back. That's right. Now the axes don't rotate. Fuck. And it misses. It still misses, and it goes too far. Okay, well, we got it to, like, kind of do something. Theta rotation axes for these. Let's just make sure we can get it to move. So, that's not right. What did I just do? What did I just do? Stop. Don't do that. Wait, what? I'm gonna times I in here. I don't know if it's that. Oh, yeah, no, okay, yeah, I realized that multiplying by I is not the same as multiplying the inside of the cosines by I. There we go. Okay, look, that's what our fixed thing looks like. This is right, but it's also not right, because it's not moving fast enough somehow. I don't know how. Now is the part where I'm like, I just don't know how, but it is better. I'm not even gonna have this note be here. That doesn't, there's no comment there. Okay. So. I don't know why this rotates up, by the way. It's a negative angle, and I put it in here, and it rotates it up. So I just... Wait, I need to Google that. Negative angle in rotation matrix. If a vector is rotated in the clockwise direction, then the angle will be negative. If we rotate a vector in the counterclockwise direction, then its angle is positive. I don't know why that's doing that. Because it's a negative angle. It should be moving it not up, but you know what? It's fine. It's fine. I'm not too worried about it. I just don't know. So if I add, what I had before was I added negative 0.27 to both of these. And I think it fixed the, oh. Well, kind of, like that. That's not what I did. That's not what I did, chat. That's not what I did. What the hell? Wait, what? Well, I guess that doesn't... I was trying to adjust it so that it, you know, went a little bit over. Or something. I don't know why that's happening. I like how it keeps stuff the same. See, look, from back, no. I was gonna say from back here it looks right, but it goes way too far. I genuinely don't know how it's possible though, because like you can see it's just a velocity that, wait, no, that's the scaling. Watching you fail at math is so much better than failing about myself. That is real as fuck. I like struggling. I think it'd be funny if I was like a professor to just be like, hey guys, it's okay. You know, people fail all the time. How has it already been half an hour? Oh my god. I'm cooked. I need to fix it, but like, how do I fix it? Okay, what if I add positive to it? What if we add 0.01 to everything? Like, just for fun, and see what that does. That might do something. Okay. That is worse. Wait, but that also didn't fix the... There's something about changing the direction. I have to cover for my professor in the big lecture hall? Scared? Oh wait, that's so exciting though. Wait, they're probably gonna be like, oh, this is so fun. Like, somebody who's like not annoyed at us. Oh, I forgot it's negative. Wait, let me like negative it up here. That gets so small. Okay, so that's not right. Holy shit. That's tiny. Okay, it's... I don't think we have to change the magnitude. I'd have to change the direction. But I don't know how. I don't know how. It should be changing. It should be going. I literally am just rotating the axes, and then... I'm annoyed at them too. Why? Why? They're funny, I'm sure. So as we rotate this, the velocity gets smaller and smaller in the rotating direction. Because as we can see, the components of this... You know, what if I graph the components, actually? That might be kind of interesting. I want to just graph this. Let's see what this looks like. And we'll make this one yellow, and the other one also yellow. Just this one. Also, I'm realizing I might need to change this. Is 1 eye and 2 eye? I take a real gander. I mean, if you want to, it might not really be... I think that's right. Let me maybe not change it to yellow. Yellow is kind of hard to see. I just want to make sure that it's like... Yeah, it does seem like we're rotating the velocity, and you know, it's happening. Now, just like, why is it not rotating it more? Should I just like Google Coriolis effect? Graphing. Oh no, these are like, uh-oh. This is grad student stuff. What if we just start adding random stuff to it? I like that idea. So one of the things that was a random add that now might work is crossing Omega with... Oh, wait a second. Wait a second. What am I doing? I need to cross it with the position vector. Maybe? Does the radius change? I was gonna normalize it, but that doesn't really help. Omega, I want Omega cross R. But like, well, I mean, I can say X2B. Let's try it. We're just trying random stuff. Maybe it'll work. Who knows? I don't know. Let's say bibbidi bobbidi boo. It might work. Is it gonna do anything? Let's see. It's gonna... Oh. A and B must be of length 3. Omega is not anything. I just realized. Sorry. Also, I'm realizing that it should be this. Can't believe... What? I don't know what... I don't know what you mean by that. Do I need to Google something? Damie doesn't get jokes, POV. What? Oh. What? Intelman? What? What? I can't believe that there's something that's just made me more confused than this already, and this is already like the most confusing thing. Okay. If I change this... This sounds like secret code. It kind of does sound like secret code. It sounds like evil secret code to me. Wait. Oh, it's so close. Wait, why does it keep going? That was close. That was close. That was close. I don't know. It's not supposed to do that, though. Like, I'm gonna be real. It doesn't make any sense why that would be there either. It's so close, though, that I wanna say that it's right, but it's not right, is the thing. Wait, let me see it again. It just goes straight past. Why does it do that? Why can't it just behave? Does it need to be omega I? Nope, no, it does. Oh, wait, oh my god. Oh my god. What was that? Oh, it just kept going. I thought it... Oh my god. Okay, so not I. I mean, it makes sense that it's not I. It makes sense that it's not I. You can't even see anything happening. Oh my god. Okay. I don't know. I don't know what it is. This feels wrong because this comes from the fact that... Hey, wait a second. I can read some notes. I have some notes. Intermediate dynamics. Here we go. Reading notes on Coriolis effect. Because I actually was late to this lecture because I was yapping with one of my professor friends. So maybe she was like, here's the secret to the Coriolis effect. Alright. Look at the components of a... No. Coriolis acceleration. Coriolis effect. Consider two people tossing a ball. What path does the... Yeah, it appears to be... Well, that's not helpful at all. It just says it appears to be curving. Coriolis effect on merry-go-round. Because a lot of people say, like, well, there's a Coriolis acceleration. There's not a Coriolis acceleration. It doesn't have an acceleration because it's in the air. It will appear to have an acceleration to the left, which is apparently negative 2 omega crossed VP with respect to O, minus omega cross RP with respect to O? Okay, maybe we just try this and we see what happens, because at this point I am out of other options. So this is omega cross R, so this should be omega cross R, which is not that right now. So let's see what this looks like first. Oh? It is closer. Okay. Then we add minus 2 omega. Well, it shouldn't be minus. I'm just gonna add them. I feel like that's working. Minus 2 times cross product of omega crossed with R. No, sorry, with V. So that would be V ball. This V ball right here where we are. If it starts tweaking, then Oh, whoops, V-ball 2B. So that's not the right direction. What if I subtract it just for fun? It's not gonna be right if I. Uh-oh. Okay, so that part is wrong for sure. I mean, it doesn't really make that much sense that that exists anyway. It's closer with the cross product, but the cross product makes no sense because when you have a thing, I guess it would be, let's see, v equals little v, or your initial, your v at I plus, wait, maybe I have to do, wait a second, okay. I think it's minus, but let's try that. Just a scrunch. Wait, why is it kind of going right? No, that's the exact same thing as it did before. How is that even possible? Wait, how is that even possible that it's the exact same thing it did before? I'm like at a loss for words. How? Oh. That is impressive that it's the exact same thing that it did before. Or it's just that it's so small that it doesn't really even matter. Thanks for watching the Ultimate Family Guy compilation. Wait. This is what Umbra sent me. This is average Damie V2 reviewer. I hope it's a good compilation. I don't know if I would choose to do that, but I don't know, chat, I'm kind of lost. I feel like this might be a lost cause. Like, what? How? It doesn't affect it, like, at all. It also doesn't make any sense that this would exist. Kind of. Just being honest. I'm thinking about it for one more second, and then we're gonna not do this. And delete it. It's not even close. It's like the same thing as... Wait, let's see how far off it is if I delete it. Oh my god, please. There we go. Like, let's see. It's gonna follow the exact same path. It's literally almost the exact same path. That is the exact same path. What the heck? How? And it's not, well, I mean, it kind of is a scaling thing. Like, there's a little bit of scaling going on. Like, if I don't graph the velocity, let's see what it looks like. But you can see that it's still gonna, like, miss. I don't know why. It hates me. Well, this is not working, so I might as well do something else. That sounds, better than this. So, we're gonna do more of this. Well, not really, but kind of. Let me see, I have not looked at these yet. Also, wait a second, let me just check something real quick. Oh god, we have a homework on axisymmetric. What? Oh, that's fine. Is homework. Okay, I don't have that. Good, we're chilling. So what am I looking at? I'm looking for the problems. I'm sorry, chat. I failed you. I don't know what the problem is. I'm actually so surprised though, because I don't know how it's getting the same number. That seems like it shouldn't be possible. Oh, we started doing this one already in class. 3D! Yay, everybody's favorite. 3D rotating axes. Alright. So they're just like, it's like regular 3D and regular rotating axes, except we put them both together. So let's see. What are we given? I don't like writing it, but what are we given? The particle P slides around the circular hoop with a constant velocity of that relative to the hoop. So R P. I'm gonna say there's R dot P. R dot P O. Fine, I'll put X, Y, Z. Sorry. I don't like, oh, we have to define our, so, yeah, we'll do it later. I'm getting ahead of myself. It's gonna be 1.2 meters per second, and then I'll say relative, or tan to hoop. Because I don't want to do that geometry right now. The hoop rotates about the x-axis at a constant rate of omega. So omega equals about the x-axis 4. Speeds as shown on the particle position, theta 45. Use rotating axis. Okay, we want to find velocity acceleration P. Ugh. Acceleration. Ugh. Alright. So omega, very important. Omega is going to equal omega. We only have one omega, so we can't really choose anything other than that. And our origin is going to be here. Kind of cluttering up my drawing, but it's fine. Alright, what are we doing? We're trying to find the velocity of P. So VP, we don't really know, well, we do know that it's going to be tangent to the hoop. Maybe. No, we don't. I lied. The hoop is rotating. We don't really know anything about VP. But we know that it's going to be VO plus omega cross RP with respect to O plus R dot P XYZ. I've yet to find a good way to write my R dots in a way that I actually like doing. Okay, VO is not moving, so VP equals omega, which we know. That's the 4. Cross RP with respect to O. Very, very chill here. It's going to be in the x direction, we get 45. Well, it's going to be 45, but cosine. So 0.2 cosine 45. And then 0.2 sine 45 and 0. Easy. And then we just have to do R, which is not particularly hard. So we know that this is going to point this way. So it's got its angle here at 45. And it's going to be, let's see, negative x. Negative x version of whatever. Sorry, my brain stopped working. 1.2. Negative 1.2. Cos. Oh, I guess I should. Yeah, no, it is cos 45. And then 1.2 sine 40? Oh, wait. Wait a second. Why is my brain not working? This direction, cosine. Oh, I guess it's not really... my brain. Okay, it's pointing this way. It's literally just pointing this way. Yeah, okay, it's sine. I don't know why that like hurt my brain so much. Jesus Christ. It's positive. Yeah. Okay. And we just have to solve for that, so that's nice. I don't know what that is, but we can do it out real quick. I'm gonna trust that I can get my cross product. Wow. Words are hard. Going to trust that I can get my cross product right. It's gonna be negative 0.2 sine 45k. Negative 1.4. Oh, that's not right. Wait, times 4. Sorry. It's also not right. Oh wait, yes it is. I was looking at, I don't know, I was looking at I. Jesus Christ. Okay, 0.57. And then negative 1.2 cos 45 is negative 0.85. 1.2 sine 45 is the same thing, so it'll be 0.85. Are you proud of me, chat? I didn't type in sine again. I knew that it was going to be the same thing. Wait, it's also negative? What? What's wrong? Why? Why? Wait, actually, why? Huh? This is negative. Wait, but does that mean this is positive? Yeah, that's right. Why is that negative? I don't see why that should be negative. I mean, if it's moving this way, then should... What? That's weird. I'm gonna put a star next to that, because I don't know if that's like... I don't know if that's a me thing, or if that's a... Could be an answer key thing. I don't want to say that it's an answer key thing, because I don't really think it is, but... Alright, oh, and the acceleration. So A of P equals acceleration of O plus alpha cross RP with respect to O. I guess we don't have an alpha? Yeah, constant velocity, so that's 0. Plus omega cross omega, oops, cross with RP with respect to O. Plus 2 omega cross R dot, I'm remembering, R dot XYZ plus R double dot. I believe P's rate is constant. P. Sorry. I'm mature. This will exist, this will exist. Okay. IJK. The only time I'll ever write IJK. Omega is 4. And then, oh, I did this in my head, but it was 0.57k. Wow, what a lovely matrix. How beautiful. How nothing. I love it when matrices are nothing. A full matrix is a little... kind of a red flag, not gonna lie. My matrix would be so full if I was a matrix. Which is unfortunate, but you know, that's just how life is. We still work with them. We still work with them if they're full, you know? What is this gonna be? I don't even know. Okay, negative. Plus, and then the 2 is gonna trip me up, I'm sure. -8 times that. And in the k direction. Please be right. Please be right. 6.8? I rounded a lot. I don't know why I rounded so much. Hey! Oh, there's some I in there. We goofed something. What did I goof? 6.8 is right, but the... Is A? AO doesn't have... There's no AO. Oh, it's moving in a circle. I always forget. I always forget, chat. I forget. There's a normal component in the this way. It goes this way, which is -x and -y. I guess it's the opposite of R with respect to O. So it would be, how do I want to say this? It's v squared over rho times, if I'm dividing by the magnitude, I'm all, no, I need to normalize it. This is gonna be 1.2 cosine 45. Nope, that's the wrong thing. I got cocky. -0.2 cos 45. -0.2 sine 45. -r here with respect to O, which I guess is just O with respect to P if you think about it. But then I need to times this by... Wait, is 0.2 cos 45? We're gonna check. Squared. No, it's not. It's not normalized. So we have 0.2 cosine 45 squared plus another one. Yeah, so divided by 0.04. It's like, I don't know, I feel like being able to normalize stuff is just really smart, you know? I think engineers, like, or the way my professor did it was like, just look at the angle and say this is over this. And I'm like, well, you could just put in the radius and then just normalize it. Like, in a mathematical way, in a computer, it's a lot easier. You don't have to manually do it every time. It might be considered overkill. Like, I'm bringing a katana to cut bread, but hey, it is working. The other thing is V, I have to do the same thing for V. Okay, this is long. I kind of need to do this out a little bit. 0.8, the 0.85 thing needs to be squared and then added twice. Times 2, and then this minus 0.7. I must go drop stuff off. Alright, bye. Oh shoot, I didn't take the square root of it. Good luck dropping things off. What if I multiply it by -1? Then my life is not bad. Yeah, 1.3. This is so much math for like such a little payoff. Unfortunately, that is like life though. 0.2, and this is not that. It's the square root of 0.04, which is 0.2. Oh, interesting. And then the negative, negative 0.2 cosine 45. This is a number, which is this. Oh, I don't have any music. So scary. So scary, chat. Sorry about that. What shall we listen to? Let's see. Oh, I'll listen to Katamari. Katamari, my beloved. I keep failing level 4 in Katamari. Guys, this is why I don't game on stream. (0.2 squared). This times negative 6. It was not negative 6. Negative 5.1. That was my impression of an angry bird. What if I just did this in MATLAB instead? It's already up. What if I just, what if we just did this? It kinda... It'll kinda work, is the thing. Is there like a norm option? Oh wait, I need RP, RPO equals cos D45 sine D45. Hey, what's up with that? Oh. Okay, and then I don't like getting an email. What email is that? Oh, it's fine. Oh yeah, my thermodynamics professor gave us our grades all out of 0. So like on our, it was like 100 points, but he like put it out of 0, and he was like, I don't know how to change it, so I'm gonna like delete it and I'm gonna put it back. So it wasn't a big deal. Okay. What do we need? We need to just say the norm. It's like norm VP squared divided by rho, which is 0.2, times normalize RPO. And this is a R dot dot. Oh, I has save it. Let me see. I'm gonna put it in here. I don't know. I'll just call it some like random calculations or assorted calculations. We'll call this 4-1. Oh, I guess that should be not that. That should be text. Let's see what this is. Does it want to... Nan? What? What? I can't normalize RPO? What if I just normalize RPO? What? Is that not how normalize works? Normalize a vector matlab. Oh, that's not what that means. Oh, wow. Okay, not what I want that. Normalize vector to unit length. Thank you. V divided by V norm. Okay, kind of annoying. Times RPO divided by norm. It's really not that bad. I'm kind of just being a big silly. Negative 6.2. Wait, but didn't I get that? Didn't I? Chat, didn't I get that though? Ooh, I did get that. Or I got something very close to that. Why is it only 2 though? What the heck? Oh, well it should be 3 dimensions. That's one thing that's wrong. But why is that? Is RP respect to O? Like it's a centripetal, not centripetal, well I guess it is kind of that, but it's like a normal acceleration to the middle. It should be pointing, yeah, 45. I don't know. What? How is it negative 5.1? Am I getting my other numbers wrong? Possibly. I don't know, I might as well just put the other ones in here. We're trying to do it this way. So let's say omega equals 4, 0, 0. And then we already have RP with respect to O. So we'll say this is cross omega RPO. No, sorry, omega cross omega RPO plus, if I run that, okay, it's a little different. It's still wrong. Nice. And then 2 omega cross 2 times cross omega R dot, and R dot is oh, okay, yeah, it's negative 1.2 1.2 sine D 45 0. I didn't multiply them. Uh-oh. Oh, oops, R dot. The last part is right, which means that this part is right, but the other 2 parts are wrong. Maybe I'm not crossing the right stuff. Maybe it's supposed to be... Maybe it's not that. Maybe it is double dot on the other one. Check. Kind of embarrassing to get my guided equation wrong. There we go. Green. Where are we? Let's take a look-see, chat. Yeah, the velocity is fine, but the... Oh, I guess if my velocity is negative, maybe it will change it. Like, let's try this. Wait, that doesn't change it at all? That seems odd. What if I clear? Just to make sure. How do I clear my variables? Close all? Maybe that's what I'm doing. Weird. That's fascinating. It doesn't change no matter which way it is. What the what? Wait, am I evil? What? When did I turn evil? Just turned evil for fun, I guess. Well, okay, that also doesn't work. That's great. Wait, let me look at... Sorry, I didn't actually continue looking at this thing. That's frames. No, this is right. Yeah. That is right. But what's wrong about it? Maybe I'm missing something? Maybe there's no alpha. Oh, I'm not. Sorry. We're not in the right place. Chat, let's go back to the room. There's no alpha. Is my Omega Cross... Oh, my Omega Cross... This is not this. Oh, silly me. That is the 0.85. Wait, no. Wait, yeah. Oh, no, wait, what? Oh, whoa. I don't know what's happening. What is... Did I do that right in this one? Oh, I did it. Yeah, I guess I did it out. Omega cross RP with respect to O. Huh. Weird. Well, I don't know why that's not right. And that's a pretty bad issue, I would say. Yeah, the only R dot double dot should be in that normal direction this way. Maybe there's something about the radius. Maybe I don't need to normalize it. Let's try that. Let's try non-normalizing it. What was it, 1 point something? No, that's also not right. Okay, so normalizing it needs to happen. Is the normal VP negative? I don't know if I can tell. Man, I wanted to win, chat. I wanted to win here. Ah, shit. Okay. Yeah, negative 0.5. So it should be like negative negative 7 or something? Okay, wait, let's check if... So these two should be like 0.75 apart. The I term and the... Oh! They are not 0.75 apart. So there's something else I'm missing, I think. When it's V squared over rho... We can't square a vector, though. So it's not like I can say, oh, maybe it's in a different direction. It has to be in the R direction, right? Like, because that's where the acceleration is pointing. But there should be more. These cosines can't be the same. Because the magnitude of these has to be different than this value here, unless I'm missing a term. It's kind of a weird thing. That is so odd. What am I missing? Is my omega cross stuff wrong? Maybe that. So omega cross R P with respect to O is this, which is just this. So that's here. Oh, it's 4. It's 4 times this. Oh my god. Okay, so that's one thing. Okay. So 2.28, so that explains that. But that shouldn't goof me up here, right? Because I put in my omega and I put in my R. Let's see what the cross product of omega R is. If I just run that. Sorry, you can't see this, but I'm just running it. What the what? Why is it doing that? It's saying that it's only negative. Oh. What? It's not saying that it's 2. What's going on? What's going on? Why is it not saying that it's 4? Wait, no, it shouldn't be 4. Wait a second, it shouldn't be 4, because... It's 4 times... Oh, wait, no, wait. No, I'm silly. It's gonna say it's 4 now? Yes, okay. Okay, slightly better. The first one's still off, but if I have like -6 and then minus 2.28, it's 8.5. That's super off. There's something wacky about the... Maybe it's something wacky. No, oh, because the velocity's magnitude isn't changing. That's why it doesn't matter if it's... Ah. Okay, so yeah, it's gotta be something with this term here. We can back out what the term is if we want to, and see what the... You know what? Why don't we do that? Let's try and figure it out. So we know that... Okay, let's figure this out. Because I think this last term is gonna be what's goofing us up here. There's something weird about it. So we know that in some way this is going to be like v squared over rho. The issue is like, how do we get there? So if we have... The easiest way to do this is going to be to use the -5.1 is the I component that we're looking for. So if we just say v squared over rho as a magnitude, what do we get? We get 0.85 squared times 2 plus 0.75 squared. Magnitude of that is, so it's 1.33 squared over 0.2. And that's going to give us... This gives us 8.849. So what we had it as was... Right, v squared over rho times 1 over r double... r... I'll say the norm of r times r. P with respect to O. Negative RP with respect to O. So we just found was this part of this. So now we divide this by 0.2 to give us what we think that is. Wait, no. Yeah, my brain hurts. Did I square it? Did I remember to square it? I feel like I didn't square it. I did. Maybe if I put parentheses around it, it'll like it better. No. I was trying to back out from 5.1. Okay, wait a second. Maybe... Okay, this can be a little bit better. We can do this with cosines instead. I think. Because r p with respect to O is just gonna be... Right, we go positive, positive. It's gonna be negative cosine 45, negative sine 45, 0. And then we don't have to deal with any of that. Then we just say 8.84 cos 45? 6.25? That's not right though. That's what I was getting before. It would also be the same. Well, no, wait, one would be 6.2 and the other one would be less. No, more. Plus 2.28 is 8.5. I don't know, what's up with that? My magnitude of V can't be wrong. There must be some other term that I'm missing then. Maybe let's try another one. See, you know, this is kind of like... This feels like the same issues that I was having last time, where it was like, I felt like I was setting it up right, but I think I'm missing, like, there's something big that I'm missing. And I don't know what it is, and it's kind of a little... kind of a little... scary. Let's see. Maybe just miraculously, and we can figure it out. Oh wait, this one is one that we can't. We can try it. You know, I actually could do one of the. Sorry, I'm just thinking about how to do this. I don't think we did enough to do this one yet. Let me try to do one of the extra problems. Because if we do one of the extra problems, then I think we can figure out what we're doing wrong. And I can try and do it like with MATLAB or something, and that'll be kind of fun. Let me just make sure, additional solutions, that it's here. Yeah, we're loading. Okay, cool. There is one for this. Alright, let's just try setting it up, I guess. Sorry, it's really blurry. Alright, I don't really have to worry about writing any of the stuff I normally write, but it's fine. This is XE1. Then rod ABC moves along, rotates at a constant rate. I will write omega equals whatever. It's gonna be omega 1. Knowing collar D moves downward along the rod at constant relative speed, the velocity of D and the acceleration of D. Okay. BD equals our origin. I'm gonna just put it at A. Origin. VA plus omega cross R D with respect to A plus R dot XYZ. This is 0. That's omega 1 crossed with, and then we'll do the rest in MATLAB. We'll set up the values because I just want to try it. Okay, so switch this over. Back. There we go. And then go back to text. Let me say this is 4.E1. Code. Alright, we need omega 1. We need RDA. And we also need R dot. Omega 1 equals, what did we have? Omega 1 is rotating at 4 radians per second about the y-axis, so that's 0, 4, 0. RD with respect to A. Ugh. Okay, so in the x direction it's 0. In the y direction we're going down 10 inches, so 10 divided by 12. And in the z direction, awesome, we're not giving anything. No, it's fine. I think it's, let's see, 3. It's halfway in between this thing. So we have, this is 3, this is 8, so this full thing is 5, so it's 2.5, but 2.5 plus 3 is 5.5. So we'll see if that's right. I mean, you know. Let's write this in feet. And then our dot is in the direction of that. Awesome. Let me just write this. 12, 8. Isn't it like 8, 12, 8, 13 or something like that? Something weird triangle. Bullshit. Okay, it's fine. U of D is 65 times 65 inches, so divided by 12. Times... Okay, how are we gonna do this? In the x direction, there's nothing, so that's easy. In the y direction, it's gonna be the sine, so 12 over... That's 12 squared plus 8 squared square root. .14 whatever that is. So 12 over... I'm just gonna do that. Right? I think that's right. And then in the z direction, now if it's negative, so we're going down in the y, down in the z. Okay, we have all our stuff set up, and then we just need to come back over here. That was my recording screen that I accidentally we have VD equals cross omega 1 RDA plus R dot. We're in the wrong section. Can I run this section? Oh. That's a thing? I don't know if it's right. Let's see if it's right. It's acceleration. Wait! Why did she scribble out the velocity? She scribbled out the velocity! Oh wait, no she didn't. She didn't. Okay. Did she find it in inches per second? I think she might have found it in... Oh, it's inches per second. Okay, so get rid of all of the 12s. It's like, oh my god. It's so much bigger. 22, negative 54, negative 60. Uh-oh, we forgot something, chat. Negative 12 over 13. Wait, that's 5? Oh, it's 5, not 8. Okay, so that's just geometry. I was right though, it was, but, you know, not the right. Okay, that's right. Now let's see if we can get the acceleration. So... No, this is good actually. I'm going back over to here. My mouse, there we go, okay. AD equals A0 plus alpha cross RD with respect to A plus omega cross omega. What is omega 1 cross omega 1 cross RD with respect to A, yeah, plus 2 omega 1 crossed with R dot YZ plus R double dot XYZ. Now, it is moving in a circle about A, so we will have something, but this is constant. This will be something, and that'll be something, and that'll be something. So these are all just things we can make up, but the R double dot XYZ equals, I don't know, it equals, it's moving in a circle about A. But when it's, okay, it's not moving in a circle around A when it's not rotating, which is what we care about. So if we pretend omega 1 doesn't exist, it's just sliding down. So this is gonna be 0. But that's bad because then I don't know if I'm doing the problem right, because I need to do one of these where that's not 0. God damn it. Okay, well, we're gonna try this. See if it's right. AD equals cross omega 1 cross omega 1 RDA plus 2 times cross omega 1 R dot. That should be all it is. That is not right. Okay. That's good. It is 0. Wait, so what the hell? How did I get it wrong? Oh, it's negative 10. Did I not say negative 10? I didn't write it anywhere. Well, I didn't write negative 10 here. R, D with respect to A. Ooh. Well, it doesn't actually change it. Oh, I scrolled too far. I don't understand why I'm getting it wrong. Oh wait, 200? Wait, I'm getting 320. How am I getting an I hat? Well, okay, no. She's getting an I hat too. But my... What? Wait, what? I'm getting 320 and she's getting 200. Is it just geometry stuff again? These are all the same values though, they should not be changing at all. Which is concerning. Am I crossing? Chat, I don't know what's going on. Okay, R dot is negative... Saying 4J crossed with negative 60, 25k. What? Wait, 25? Oh, it's 5. There we go. Okay, so that's just geometry, but that's like... I guess this could just be geometry, but it doesn't feel like it's just geometry, you know? It feels like it's really off. Growls. I don't know. I don't know. Also, I don't know why this doesn't work either. This one's so sad. I want it to work so bad. Like if I crunch it in my mind. Wait, let me look at one thing with this. I want to see one person. Yeah, it's landing the wrong place. I don't know a single person who has shown me a picture of this that looks correct. I don't know if it's possible. It feels impossible right now. Like I just, yeah, I don't know. I don't know, chat. I think we're done forever. I think we're going in the garbage can. We're going in the garbage compactor. Say it's wrong. I don't know why. If I just start like subtracting stuff, then it might work. But it doesn't seem like that's what I should do. Maybe it's my... Like, the only thing I can think of is, like, maybe it's this? Like, what if I said I1? Nice. Oh. Unrecognized function R. Good start. Let me run it real quick. I'm just balling. Sitting in silence, staring at my grimoire while it runs. Wait. Index must not exceed 3. Oh. Oh, I guess that, no, that makes sense. That makes sense. That makes sense. Well, that's all I got, chat. I don't know what to tell you. What if it just miraculously works this time? No, it doesn't. Okay. What if I just made it like a little faster? Like, what if I just like said like I'll go like a little faster? You know? Like, what if we just did that for fun? You know, like as a fun kind of little. My mouse is out of battery. Oh no. Oh no. Okay, well, we'll try to not use the mouse. Left-handed mousing on my trackpad. What's happening? You know, okay, actually, here's something that's productive that we can do. I can at least answer the questions, because there are some questions I have to answer. That seems like a good thing. Maybe we will find something. We're not gonna find anything. I don't really know what I need to submit either. Oh, okay, no, I do. Alright. Part 1. There's some calculations I needed to do that we can redo real quick, digitally. Let's put it in here. Why did I not have a week 2 lab? Or is this the week 2? That's the week 2 lab, I think. Yeah. Let's say, that feels odd. Okay. I need to just show that I can break a vector into components. It's just like this, and then like this. Maybe it is something with the components. That'd be funny. And by funny, I mean I would lose my mind. It's P, and P is like 3, 4. Yeah. Okay, so A. We want to sines and cosines and projections. Yeah. So we say theta equals, I guess, it's gonna be, how do I want to do this? Okay, fine. Theta equals tan inverse of 4/3 equals something. .1, and then E, let's call this x1, or x2. E x2 equals 5 times cosine of 53.1 minus 15. y2 equals 5 times sine. There's no way you would ever do like this in a program. That's just silly. This times 5. It's 3.9. 3. And then 5 times sine. Oops, sorry. Minus 15. 3.09. And if we do it with the rotation, then we just say we're rotating up 15, so it's like cosine 15, sine 15. There's a negative somewhere. I think it's this one. I need to look at rotation matrix. It's negative sign on the top. Times 3, 4. So it's like 3 minus 4 sine 15. And then. Is that right? Why do I write 0? That's not right. That's not right. I hope that's right. I could just say that it's right, and it's not. It's not gonna be it. But let's see, 3. This doesn't work. I'm gonna cry. Why did it work? No. Wait, but I'm wait, why would it? Oh. Yeah, that should work though. What the? Am I just multiplying matrices wrong? Possibly. Either that or it's... No, it's negative sign at the top. Sighs so sadly and deeply. How is it not right though, is the thing. Wait, okay, I did this out. I can just check. Not that. There we go. It is negative. What the heck? Is it negative on the bottom? It should be negative on the top. Maybe it's... Oh, it is negative on the top. What the heck? Why is it lying to me? That's a plus. Okay, sure. That's right. Whatever. Cool, okay, that's the same. That, I think, is all the hand calcs I have to do. Which is nice. We need to submit. What are my deliverables I forgot? Showing your hand calcs for... Whoa. Finding the velocity of the ball in a rotating frame? Yeah, do we have to do that? Wait a second. My hand calcs for finding the velocity of the ball in the rotating frame? Maybe this is what it was... Okay, maybe this is what it's trying to say, but like, I don't think you need to do this for that. Because you can just rotate it. There doesn't need to be any hand calcs for it. Okay, fine. V of ball in frame. This would be... Okay, our axes are rotating this way. Well, but our axes aren't really rotating that way. V is rotating this way. It's complicated. Well, I guess if we could argue that it's kind of like the same thing as saying this. It's just a sign thing. It's like whether your V is... It's just like cosine omega times dt. And then sine omega times dt, and then negative sine. Times v I equals v I plus 1. That's all it needs to be. I hope he doesn't want us to split it into a trig. That's like, you don't need to do that. Ooh. And then a report showing all requested plots and numerical values seem to be fully I don't know if they want... I'll have to ask him tonight, but he was saying like, oh, you can use your file as your report if you set it up right. Your MATLAB file. So like... I mean, this kind of has the requested stuff in it. You know what I mean? It also has a bunch of other stuff. Like the code that we don't need. Is there a way to like turn off all the code? Like hide all the code? No. I did not mean to do that. Oh my god. I don't know what that did. It's fine. I don't think it did anything bad. I can always just close it if I want to. I'll just run it. Yeah, I don't know. It's weird, chat. Look how great and perfect it looks here. Like how it works. And then, you know, how it like works here too. And then how it... Oh. Oh, it's because I changed this and I undid it. And then how it fails. Every time I see it, I'm like, wow, it's so close to right, but it's not. You know, it's interesting because there was something I was doing earlier, like my other version of this, where it was doing a very similar thing where it would miss it. And that was when I was doing rotation of stuff. Part of me wonders if it's the dot product. But then I also, when I graphed it, it didn't look wrong. It was showing it sort of rotating, you know? Well, that's all I got, I guess. It seems like it's also... It feels like the V is too large, if anything. Because like if I shrink the V... Oh, let's just say I say like minus 0.01. If I shrink it just a little bit, that'll be too much. But oops. Let's see if it gets closer, because it feels like that's why it's going over. You know, it's not that it's turning too much, because even if it turned more, it would still... Yeah, it's definitely shrinking it too much there. But there needs to be something to... I guess arguably, you know, if you're shrinking the Not like there's wind resistance, that wouldn't shrink the V. It should just change direction, I guess, but like with the Coriolis acceleration? But with the, if it's the Omega across R, that makes sense. The Omega cross R comes from the motion of the turn. But the, okay, maybe it's Omega, the Omega R dot term can stay. So that would be 2 times cross Omega norm and R dot, which is, in our case, is V ball I. Oh, V ball 2B. Are you using cross? Oh, yeah. Well, now see, that's, it's gonna go too far. It's gonna go too far, I'm calling it. It's gonna, like, curl in now. Yeah, it curls in way too much. So, it's not... Wait. But, yeah, because that's DT. That doesn't have any I in it anywhere. Do I need to normalize that? I don't think so. That would be what it is. Yeah, I got nothing. Omega norm is already tiny, yeah. If I did I, then it's gonna like start spinning off. But really there's nothing else, like there is no acceleration. There is no part of the Coriolis that is an acceleration, it just looks like there's an acceleration. And we see it curve already from the fact that our axes are changing. But it just doesn't curve enough, which makes me think there's some tiny little thing that I'm missing. Well, I think I'm gonna call it early because I gotta do some stuff before I go to this class, and I also gotta figure this out, which is unfortunate. But I will update when I get an answer to it. Which, man, I don't like it when I can't solve a problem. It's always sad. I feel like y'all can relate. There's some, like, I still don't know I'm getting that other problem wrong either. Like, I don't know, it could be a million things. Probably my geometry, which is always frustrating because the geometry, I feel like, is more of the trivial part. It's not really whether you know dynamics, it's whether you know geometry. And you're like, man, I don't want to get this problem wrong because I don't know geometry, but then it's like, oh damn, like I don't know geometry. So I'll go study geometry. I'll go back to 8th grade and I'll study geometry, I swear, guys. It's hard. Sometimes the numbers look like they're other numbers. What am I supposed to do? Know all the numbers? Ugh. It's too many of them. Well, I'll be back on Thursday. And we won't be doing this. This will be solved. This will be mega solved. And I hope y'all have a good couple days. And I'll see you then.